Quality and Customer Satisfaction. This presentation examines Case Study 6.1 from Donna Summers' Quality textbook. My name is Krista Smith, and I made this presentation for a statistics class taught by Dr. Dana Inglesby at Jacksonville State University in Jacksonville, Alabama. Just as an overview, I will start with the problem statement and move into the more specifics, such as production and management strategy. Next, I will discuss how the data was collected and go over the diagnostics from the data. Additionally, I will discuss some key observations made during the problem-solving phase, some new data samples, and my recommendations for Whisk Wheel Company in the future. Whisk Wheel Company has just been notified by its largest customer, Rosewood Bicycle Incorporated, that the quality level of the hub must be dramatically improved. Upon the initial contact, Rosewood employees were sorting through the parts on the production line. However, they insisted that WWC must immediately begin providing statistical information about each lot of products they produce. At the end of each day, the lot is sent to the Rosewood just in time for their production run. The production of the hub shaft in question is initially a 12-foot long chrome moly steel, straightened and then cut to a 3.75-inch shaft. The diameter is 0.740 inches, but the dimension in question is the length, and the specification limits are plus or minus 0.005 inches. Management strategy was to intensify the product inspection. This would prevent improperly sized shafts from being sent to the customer, but it does not get to the root cause, and 100% inspection is not cost efficient. Data samples were collected from 6 hubs 24 times per day, which set at every 18 minutes, started at 7 a.m. and ended at 2:36 p.m., and that yielded 144 data points each day. The data was collected over 4 days from one single machine, and after day 2, implementation of changes began. Initially, a cause and effect process chart was created to determine areas that we should consider to look at for what is causing the variation. As you can see here, as for subgroups, we looked at the operator, the machine itself, the material, and the methods being used. From day 1's initial data, we created a frequency table or a histogram, and this showed us a bimodal distribution of the lengths that were being generated from this one specific machine during this one workday. From there, we created a X-bar chart. The X-bar chart shows that the data points are too various and not predictable, not under control. Additionally, we created a range chart from this. The range is spread out far too large beyond the acceptable specification limits, and we have too many parts being created that do not meet the requirements of the customer. So, after looking at the data, we decided to make some observations. First, we observed the operator and noticed that the operator was over controlling the process. They were taking a random average about every 5 minutes and adjusting the machine according to this random average, therefore adding variation. They were, in turn, reacting to a very common cause. This was decrease in quality and was a loss of production time. We also noticed that the measuring tool the operator was using was much too small and not nearly as sophisticated as the options that were available. So we decided to get a new measuring tool and train the operator on how to use that measuring tool so that we could be certain that the data that we were gathering was indeed accurate. Lastly, we noticed that there was slag getting stuck in the jig, and so we decided that we needed to do something to prevent the slag from building up within the jig. So we cut a slit on the back side of the jig to have a way for the slag to escape, and we also added a solvent to have a way to flush the system of the chips. This X chart represents the new data samples that we collected from day 4 after implementing the change. We can see that the range has decreased greatly, and therefore the acceptable values set by the specification limits, all of the data points that we collected from day 4 were within the specification limits. So going forward, my recommendations for Whiskville Company is we just need to show Rosewood the data. Show them the charts and show them the data that we have collected, and you can clearly see that we have made significant improvement. And then additionally, we should provide logs for operator training for the new tools that we have in place so that they can feel confident that all of our employees know how to use the tools and that the data itself that we have provided is accurate. And additionally, I would suggest providing photo evidence of where we created the slots and the solvent for the jigs so that, once again, we can give them confidence that we have addressed the issues that we discovered during our diagnostics. Thank you very much.